Hello everyone. Today we are back again with a new topic of fluvial geomorphology. Before talking of the topic, I'd like to request every one of you, especially those who are new to our channel, to please subscribe it. Just click the bell icon for subscription so that you can get a new update as soon as it has been given. And if you like the video, then please click the like button and share it up. So we have learned about some features of fluvial geomorphology, especially the processes and what is fluvial geomorphology, the erosional processes, the erosional features that has been formed by the geomorphology. In this, we are going to learn more about some of the things related to the geomorphology of fluvial landforms, especially it's the work of transportation and its depositional work. In the transportation by the river, the word transportation basically means movement. So if it is by river, then it will be the movement of dissolved materials. Now what are the dissolved materials? It will be of carbonates, the sulphate, the chloride, the oxide that are being carried up by the streams. Basically, this transportation is being done in a chronological section or order, starting from suspension, saltation and traction. In the suspension, the suspended particles consist of mud, silt and fine sand, and it is almost seen in every part of the transporting sediment of the river. While in the saltation process, it has been immediate sized of particles when it is become too heavy to be eroded, so it becomes suspended and they bounce along the bed. While in the traction, the small particles such as the coarse grain of the sand and the coarse pebbles are too heavy for the saltation to be transported by the river from one place to another. In this, the particles are called the bed load slide or the roll along the bed as a result of the mechanical drop and push of the turbulent water. So this is how basically the transportation work of the river takes place. Next, we are going to identify the depositional work of the river. Now before we go to the depositional work, we need to see what is the deposition. Deposition is the built-up processes. Now the built-up is mainly being done by the river. That is when the velocity of the river water is reduced, some of the load is being deposited. This decrease in the turbulence may always be due to the same effect when the heavier and coarser materials are being first deposited, flowed by the fine salt and the mud. These materials can be dropped at all the points of the river's course. So basically, deposition is a formation of the process that has been formed by fine salt and muds and dropped at any point of the river courses. Now deposition mainly takes place due to a various of causes. The first one may be the break-in slope, where the stream leaves in the hills and enters into the plain. It may be due to widening of the valley floors, which is mainly seen in the flood-prone areas. It may be due to contact of the quiet water, which is when the swift-flowing stream enters quiet waters or lake. It may be due to where stream peters out in arid and desert regions, and this causes a decrease in the river energy and allowing the sediments to be laid down. It may be also due to river debouch in the sea. So these are basically the causes that are features while the depositional process takes place. Now the depositional features, like we have seen in the erosional features, they are formed maybe of V-shaped valley, gorge, canyon, various meanders, oxbow lake, cascade, cataract, etc. Similarly, depositional features are there which are being formed by the river. The first one is the alluvial fan. So what does this alluvial fan mean? This is a heavily laden stream reaches plain. Its velocity is being checked and it widens and much of its load are deposited. So these loads are being deposited in sediments and these are being spread out as alluvial fans. These are developed mainly where these competence tributaries converge with the lower competence streams. So in this diagram, it has been seen these heavy materials of the river are deposited, giving in a fan-like structure. So this fan-like structure which have been formed are called as alluvial fan. These are formed by the depositional features of the river water. This is an example of the Koshi River in India, which has built a large alluvial fan. This is an alluvial fan which has been made by the river Koshi. The next we have the alluvial cone. Basically both are same except the inclination that has been taken place. In an alluvial cone is a typical of alluvial fan, but in which the slopes in an angle are steeper. That steeper is specifically of 150-degree inclination, and the deposited materials are generally coarser and thick, having been transported by ephemeral or short-living torrents emerging into the high rocky massif at a mountain front or in the valley side. So here it is seen this inclination is about 150-degree. This is a basic difference between the alluvial fan and a cone. This inclination gives rise to a cone-like feature, and if we compare this cone with a fan, this has been much formed with a coarser and thicker materials that has been transported by the rivers. The next we have a PIEDMONT alluvial plain. In this alluvial plain, it has a best example is the Eg-Indo-Gangetic plain, which is being seen in the southern pediment of the Himalayas. Here the widely closed spaced streams discharge from the mountainous regions across a pediment. Their coalesce, that is merge laterally at the base of the mountains to form the PIEDMONT alluvial fan. So these have been closely spaced in this diagram. If we see, the streams are very closely spaced over these areas, and this is mainly seen in the mountainous region where the pediment laterally merge and the base of the mountain giving rise to this alluvial fan. In this diagram, which is drawn in here, that is a replica, shows that these closed mountains over these areas form the ephemeral streams are so close towards each other, giving rise to this PIEDMONT alluvial fan. The next we have a floodplain. We are very familiar with the term of floodplain, and we know that this floodplain is being formed in an alluvial surface that is adjacent to the channel on either side, and it is frequently inundated. So floodplain size generally relates to the discharge of the water. Recently we have a great flood over the Assam areas due to the river Brahmaputra. That is, this all are the floodplain areas. Now we need to identify why this floodplain is being caused. Basically it's an alluvial surface that is adjacent to the channel, and this has been inundated. So these areas where the river flows in this side and these areas adjacent to it is known as a floodplain. There are two major ways in which the floodplains are being formed. Basically, one is vertical assertion and another one is a lateral assertion. The last one is the Iceland formation and the channel abandoned. Vertical assertion means the places where this vertically it has been formed in these areas, and it is seen in these pictures it has been formed vertically in both the side, while lateral it has been formed in a lateral manner. And in Iceland formation it has been seen that in all the areas a river is flowing, leaving the middle portion isolated or being aloofed from the rest of the areas, giving to the rise of Iceland, and it is a channel abandoned. The next we have the types of floodplain, which consist of convex floodplain, flat floodplain, PIEDMONT floodplain and compound floodplain. The complex floodplain developed due to the deposition of the bed materials as bars is slow cohesive, outer banks erode slowly but finely grained loads, and it has been deposited rapidly in one blank. This is an example of convex floodplain in Budzar, while the flat floodplain is being formed in these areas. This shows a characteristic of the flat floodplain. Well, next we are going to identify of the natural levees. Floodplain and natural levees are more or less similar terms, especially it differs in some of these features, like it is a narrow belt of ridges that has low height built by the deposition of sediments and by the spill of water over the streams on either side of the bank. So if this in this diagram, if we look after this, when the rivers flow, the side which has been stiffened up over these areas give rise to this natural valley levees. In this also, if we see that the river is being flowing over these areas, and this slightly upmerged area that has been occurred, it gives rise to the natural levee. While the natural levee is mainly seen in the China, it occurs as a formed depositional sediments during the flood periods, where the water overtops the river bank and it has been spread, and adjoining floodplain long ridges of low height have been formed over the areas and the parallel to the flood river valleys. This is an example of natural river levee which has been seen in China. Then in the next we will move towards the formation of delta. The famous delta is of the, we have seen it is in present India, that is a delta that has been formed by the Ganga Brahmaputra. So what is a delta? Delta is a depositional features that has been almost in a triangular shape at the mouth of the river, that is debouching on either side of the lake. So if we see, this is a remote sensing picture showing how the delta formation look in a satellite imagery. While in this we see that it has been formed in a triangular manner where it meets to the nearby sea, or it has been debouched on either side of the sea or a lake. So see, this has been formed in a triangular manner. So this is a formation of delta. Next we have favorable conditions on delta formation. Not every rivers can form delta. Delta has been formed only on the specific characteristic of the river, which like the suitable place in the form of swallow, sea or a lake shore. The river must be of long course river which has all the three stages predominant over it. The median size is of sediments. Should be of relatively calm or sheltered sea at the mouth of the river. It should contain a large amount of sediment supply so that it can form a delta. The accelerated rate of erosion in the catchment area is over the concerned river, and this should be all stable condition of the sea coast and also on the bottom of the ocean. Next we are going to see the classification of delta. Basically we have identified the delta will be of triangular shape, but in this triangular shape also it has been of different types. Specifically it contains of arcuate delta, bird foot delta, estuarine delta and truncated delta. This has been emerged by this picture, but we are going to explain it. I am going to say what is this truncated delta. That is when the sea sends and the river meets at its work. I will explain the truncated delta as it has been not being seen clearly over this slide. So first we have arcuate delta. It is formed when the delta is an arc of a circle or bow. So here if it is see, the delta is formed, basically it is triangular shape. Laterally it is in this type of shape, but it is an arcuate as it has been in arc like structure in the middle portion if we consider it and look it in detailing of it. So wherein there is a middle portion has a maximum extent towards the sea, whereas a narrow bottom down towards this margin. Bird foot delta. As the name suggests, the delta will have its imprint as a bird foot. So what is it? It will have a shape of the foot of the bird that will help in the formation of the deposition of the finer materials. So if we look at this, it has a deposition of the bird that has a finer material of it, like look at the delta, it's basically a triangular shape if we look in detail, but it has like a imprint of the foot of the bird, so it is known as a bird foot delta. Estuarine delta, it is very much common, where it has been seen the deltas are formed by the filling up of the estuaries of river. So this is a river which has been flowing and has been debouched by the sea, giving rise to the formation of estuarine delta. While in the truncated delta, the sea meets and the sediments have been formed, giving in a truncated structure. So this is an example of a truncated delta. If we see, the sea meets and it has been huge, giving structure of the triangle, and it has much of the land over in both of the sides of the river. So this is an example of truncated delta. Moreover, this arcuate delta is being seen in this image, where it has been, the whole is in a triangular shape, and this is in arc-like appearance, which is maximum extent towards the sea and narrow down towards the margin. The next we have the delta classification on the basis of the growth. First we have a classification on the basis of shape. The next is on the basis of the growth, that has content of the abundant delta, block delta. That is abundant, it means that when the river shifts its mouth in the sea and the ocean, the new deltas are being formed while the previous delta is being nourished. We know that the river has a common feature of moving. Sorry for this. We know that the river has a trunk. Abundant means the river has a feature of moving its course after time to time. So if it has been moving time to time, it changes its courses. When it shifts its course, a previous delta has been abandoned or left unnourished, giving rise to its abundant delta. So in this diagram, if we see that this is a previous course which is left unnourished when the river shifted its course to this area, while in the block delta, these are formed when these deltas whose seaward grow is blocked by the sea waves. So in this, river is being moving in its own way, but the areas have been blocked by the sea waves or due to erosional activity, giving rise to this block delta. The last but not the least, we come to another and the last classification of the delta on the basis of the geometry, that is high destructive delta and high constructive delta. We need to see the delta sometimes destroys the area, sometimes it gives to construction of area. When it gives to construction, it is dominant by a large debris supplies from the river, while in the high destructive delta, these are being dominated by the removal of the rich debris by the wave and the tidal course, so that the tributaries remain very stable position. So at last we come to the end of this fluvial geomorphology. If you like our video, then please click the like button and share it. Thank you.